And we are live. Welcome everyone for those who are joining us on the Zoom or on YouTube. Really excited for our meetup. It's the 21st meetup. So really excited for it. If you want to check out the previous ones, you can check it out on civo.com. But today we're talking about the future of K3s and Kubernetes. Before we move forward with the agenda that we have over here, as we mentioned previously, if you have any questions, if you're joining from YouTube, feel free to put it in the chat. Or if you're joining on Zoom, please utilize the Q&A section. If you have any feedback or anything else you'd like to share apart from questions, you can utilize the chat. If you have questions, please utilize the Q&A section. And let's get started with it. My name is Kunal. I work as a developer advocate at Civo. I'm really excited for this session. And Kai, would you like to go next? Introduce yourself.
Hi, everybody. My name is Kai. I work as a developer advocate / developer at Civo. So I do a bit of the sort of developer advocacy stuff, but also writing some web software.
I'm Dinesh. I'm CTO at Civo. So kind of responsible for a lot of the tech that we choose, a lot of tech that we kind of implement out in production and some of the choices, and kind of also looking at the future direction of all of like Kubernetes and K3s and trying to make sure that Civo is kind of staying either at the cutting edge or keeping pushing forward and keeping up with the pace of where the industry is going.
Hi, I'm David. I am one of the research and development engineers here at Civo. Most of my day is filled with playing with new technologies and figuring out exactly how they can be added into the platform or into our development platforms.
Amazing. Well, thanks for joining everyone. And this is, in terms of engagement, I'm seeing like close to 30 people. So I'm really excited about that. So the agenda for today is like, we're going to obviously discuss about K3s. It's designed to be single binary, like really small size, and it's recognized by the CNCF as well. So we'll talk a little bit more about that. Dinesh and David, they're also going to share how we use K3s at Civo and where like the future is headed, and sort of like compare it with Kubernetes as well. So let's dive straight into that in itself. Maybe David would like to kick us off with the question we have over here, which is, where is Kubernetes headed?
I think I'll start that one off. Kubernetes is headed into what I feel is a fairly surprising direction from when I initially started playing with it years and years ago. I feel it's being moved a little bit more to the background. Instead of being something that humans interact with, it's becoming more and more nothing more than an API for Linux itself. And a lot of the actual CNCF projects have kind of moved into that direction where they're using the underlying Linux utilities and the underlying Linux principles and really just building on top of those. And you see more and more of that every day here at Civo as well, where we're orchestrating our entire platform with all of our Linux base hosts and the tenant clusters themselves with their Linux machines. We don't ever really touch those. It's all done through the Kubernetes API.
Yeah, I think that, I kind of agree with that. That Kubernetes has become the ubiquitous way of deploying applications, right? So it used to be the case of you needed to get your Linux server up, install your packages, and do all of that. But now Kubernetes is that way of just defining your YAML, pushing it out there, and then Kubernetes is managing a whole set of all of that for you. I think we're just at the start of where we are with that journey with Kubernetes. I know when you're in the cloud native environment and all you hear day in, day out is Kubernetes, it seems like, well, why would you need to talk about anything else? But the reach of Kubernetes out into the wider IT industry is just growing and growing and growing. And talking to some of the unique places that Kubernetes is being used and being trialed in large enterprises and large organizations is really highlighting to me the reach that Kubernetes is about to have and how ubiquitous it's going to be in every single place IT is deployed.
I would just like to add one tiny bit to that, which is, so the whole concept of cloud native, right? I think Kubernetes slots into that super well in that it becomes the like the operating system of the cloud. So like David was saying, you're kind of like one level above the operating system really, but for all intents and purposes, Kubernetes might as well be the operating system of cloud native. So if you're thinking about, shall I deploy something on the cloud or in a cloud environment, you're probably doing some or all of the things that Kubernetes does, whether you're doing those manually or through the actual container orchestration itself.
Yeah, absolutely. A large portion of Kubernetes magic is automating very old Linux technologies. And if once you start diving into the mechanics of things, it's a lot of aha moments as you go back to reading the LARTC for the first time 10 years ago and say, I remember how to make a tunnel like that. And that's all it's doing in the end. And I think it gets lost a lot on people that it's just Kubernetes is just Linux.
Yeah, and the interesting thing about it though is that it layers on top of all of the distros that we currently know and use, right? So if you deploy Kubernetes, it's more, or it's less of a conversation about, are you deploying on top of Ubuntu or Debian or SUSE or RHEL? That is less of a concern because Kubernetes tries to sit on top of the operating system and give you that standard interface to start deploying workloads to. Which is a really interesting place to be, unless maybe you're an operating system developer. Maybe that's less interesting for you.
When we talk about where it's being headed, can we say that it's more of a control plane for abstractions? When we talk about CRDs and stuff, where do you think that the whole abstraction picture comes in when we talk about the future? How is it going to look like in terms of that?
I guess where we are today with Kai, we can't hear your mic yet. I know you've just swapped over, but where we are today with the abstractions that we've got with YAML, it's really allows you to define a lot. If you start going down creating your own operators and your own custom resources, you've got a huge amount of flexibility with the definitions that you've got. For more regular users, I think we're going to see these YAMLs like a stateful set become more and more used over things like a deployment. So these things that wrap other existing deployments and pods or even stateful sets and reuse them in a way like a MySQL operator. So you're defining MySQL that gets deployed onto Kubernetes, which under the hood will use stateful sets and pods and deployments and PVCs and ingress rules, and all of that will all be encapsulated in a single YAML file for a database. And that's what you deploy out to Kubernetes.
Hopefully you can hear me now.
Yes.
Okay. So what I was going to say is that it's almost like that next step above from when we started using container images, and every time you deployed a specific container, if say you're using Docker and you have a specific container image, what you're going to get every single time. It's that particular thing, and we're just going to add, like you said, like all the other CRD custom resources and other definitions on top of that to get a more fully fledged application all in one, isn't it?
Yeah, I mean, at the end of the day, we're slowly realizing that we don't care about pods. What we care about is how pods are orchestrated together with the application that's inside it. And we're now trying to encapsulate that logic somewhere else in a higher level of abstraction. So take MySQL. We don't care that there is 1 or 3 MySQL pods running. We don't care where they're hosted, what underlying compute nodes that they're on or anything. What we want to consume is MySQL. We want it to be highly available. We want it to be performant. And that's what we're defining. We want MySQL. What everything else is for Kubernetes to sort out and do its magic with.
There's a question that Sid has asked. Kai said that Kubernetes is an OS for cloud native. From my understanding, Rancher also does nearly the same function as Kubernetes, because you consider Rancher also to be an OS.
I'd say, David, why don't you take this one?
Yeah, so I think I'll answer that one. So the Rancher control plane that you're speaking of, I believe, is the standard Rancher that we, let's see here, that has, that's normal Rancher. That is more or less a way to provision Kubernetes clusters and then have a unified control plane on top of that. So you can provision a new Kubernetes cluster in a GKE region or AWS or even bare metal. I used to use that for my VMware lab for quite a number of years, and it was nice. You could have a single click button operation and you would have a nice functional Kubernetes cluster a few minutes later. But it's not really another control plane outside of a way to manage Kubernetes clusters.
I guess Rancher as well. It doesn't actually, it's not Rancher on the operating system, right? Rancher is just that control plane that sits on above, gives you the dashboards, give you access control, and is like a control plane above multiple Kubernetes clusters. And each of those could be on different OSs, they could be in different providers, be provisioned differently, have different access control and all of that. So it's a different layer of control plane, and it's probably that, again, that next level of abstraction that we're asking for from Kubernetes.
Cool. I believe that answers the question. Thanks for that. The next, let's start with the K3s discussion. For folks who may be new to it, Kai, maybe can you tell us a little bit more about what K3s is and how does it differ from Kubernetes?
Yeah, so David just talked briefly about Rancher, and K3s came about as a project from Rancher Labs, and it was designed to be smaller than the sort of upstream Kubernetes. So that's why it has a smaller number than the 8, right? So it was designed to encapsulate everything into a single binary. So it's a single executable that runs both the sort of the control plane, the server side, and the agent. So you could join nodes, whether they were physical nodes or virtual machine hosts or anything in between. You can join them using basically a single command. So it was trying to make creating clusters and joining clusters into sort of joining nodes into clusters as sort of simplified as possible. And the other thing that it did, aside from sort of upstream Kubernetes, which is every possible option under the sun is bundled in, it kind of goes, well, instead of by default, instead of etcd as the sort of key value store in the control plane, it uses SQLite. It bundles in a specific ingress controller by default, rather than making you define it as part of your cluster. You can customize it, but the other thing, well, basically the idea was you would have batteries included, so you could just start up a cluster and it would suit most use cases. In terms of sort of how it differs from K8s, I guess the biggest sort of difference would be the fact that it doesn't bundle. K3s does not bundle in all possible sort of cloud provider specific bits of code. That said, those things are changing as well. So K8s isn't quite the sort of big plethora of different services that you need to know to either activate or disable in your sort of, whether you're creating a cluster through kubeadm or not. It's becoming a more streamlined thing, as far as I understand.
Yeah, I mean, you've touched on a few great points there, Kai. I mean, one of the things I think about K3s is that speed of getting a cluster up and running. I remember not too long ago, trying to get a Kubernetes cluster up and running, you needed to get your initial root certificate. You needed to then sign a certificate for every single one of your nodes. You then needed to get etcd up, which was getting quorum, getting that all running. And, it took a week at least, if you knew what you were doing, to get a Kubernetes cluster up and running. With K3s, I remember the initial version, seeing that, and you just go, what? There are 2 commands? K3 server start.
K3s server join, yeah.
That's the K3 server join, and that's it. I mean, it was absolutely crazy. And that's one of the huge things about K3s that it brought. And this was probably in a time before projects like kubeadm that were trying to do this same thing of helping you bootstrap a cluster. But just that initial setup is still one of the fastest ways to bootstrap a cluster, I think, at the moment in the industry now, is those 2 commands of download the K3s binary from GitHub, server K3 server, K3s worker, go, done.
And one of
Yeah.
the big things for me about it was the fact that in terms of container orchestration, I had briefly used Docker Swarm before I started using Kubernetes as part of my work at Civo, and the sort of the approach that K3s took was reminiscent of Docker Swarm.
I think, have we lost Kai?
I think so.
Or Kai. One thing that I would like to add about K3s that is different from most other, I think every other Kubernetes distribution, is the inclusion of all the supporting binaries. It ships with its own containerd, it ships with its own library sets, it has everything that it needs. So you don't actually have to massage the host OS before you provision that node. It's fairly OS agnostic as well. So it'll let you pretty much take an install of any operating system and turn it into a Kubernetes node without really complaining about much.
Yeah,
And it's
as-
go
ahead. No, I was just saying, when we talk about K3s, folks often also refer to edge computing. So that was like a follow-up question I had for Dinesh.
Yeah, I mean, it's got this kind of marketing strategy about edge computing because of what they've done to reduce the size of the install base. So I think, as Kai was mentioning, the history of Kubernetes was, if you wanted to get something included with Kubernetes and you wanted to get your cloud included, is you committed directly into the main Kubernetes core code base. So take, for example, load balancers. So if you are in Google, or if you're in Azure or AWS and you request for a load balancer in Kubernetes, there's a bit of code that will go out, talk to the cloud provider, provision a load balancer in the cloud provider, and then report back into your Kubernetes cluster saying, yes, it's provisioned, here is the IP address. And historically, all of that work was done in the main Kubernetes code base. And this is for lots and lots of services, things like volume attachments, load balancers. There are a few others as well, but there's a huge amount of code that is very specific to individual cloud providers. And what K3s did was strip all of that out and say, well, you're probably not hosted in Google, so let's take that out, but give you the option of putting the certain bits of code back in by running a certain container in your cluster if you're in Google, or if you're in AWS, or if you're in a Civo, for example. And those are called cloud controller managers. So K3 stripped all of that out, which made it a lot slimmer to run on edge devices, which generally have less resources. And also, edge devices are not in one of these big cloud providers. So that was one of the big benefits that K3s had, and why it's a really good option for being on the edge.
Thanks for sharing, Dinesh. Still waiting for Kai to join in, but I believe we can move forward. So we talked about Kubernetes, we talked about K3s. Let's also discuss a little bit more about in terms of applications, is K3s the same as Kubernetes, or like better than that? And how does it compare with Kubernetes? So basically, like, we can start with this question. Can I do everything that I want to on K3s that I can on Kubernetes?
Yes, but it depends. I mean, just take some of the examples that I've had there about, if you're hosted in Google Cloud and you deploy K3s, you need to then put your extra bit on code, your extra containers in there to talk to Google Cloud. But other than that, that's the only difference between kind of upstream Kubernetes and K3s. Everything else you can do on full fat K8s, as I like to call it, you can do on the slimmed down K3s. Welcome back, Kai.
Sorry about that.
No worries. While we have Kai, we have the question that we were discussing. I'd love to hear your views around, is K3s the same as Kubernetes, and or is it better, and how does it compare, since we've talked about both?
Yeah, so sorry to drop out, so I may be repeating here, but annoyingly the answer is it depends, but most likely it's just as good. So I just caught the tail end of what Dinesh was saying. It's like, unless you need to do cloud specific things, you might as well try K3s on it. if you need fast startup times or are running on resource constrained nodes, K3s beats out quote unquote full fat Kubernetes.
I think also that speed of launch has probably been met now with projects like KubeADM and CAPI are also looking to solve the problems about CAPI is cluster API provisioner. And these are projects to help speed up the build time and launch time of Kubernetes. And these are all very recent projects. Even in Kubernetes world, recent is a couple of years, but yeah, these are still very new projects that are helping solve problems that still exist, getting Kubernetes up and running.
Amazing. Thanks a lot for sharing. There was one question, I believe we answered that. Cool. Now moving forward, which is sort of like also in the title for this session, can you touch upon where K3s is headed, Dinesh?
Yeah, I mean, the thing about Kubernetes is that the stuff I've been talking about of stripping out cloud provider specific code is a goal of upstream Kubernetes. So they are working with these big cloud providers to get their CCMs, cloud controller managers, and their container storage drivers as well, ready to handle Kubernetes without their code being in upstream Kubernetes, upstream full fat K3s. So once that happens, there's actually a really nice set of patches that K3s applies, which you can see how much code is being removed out of upstream Kubernetes for every release. And that change, as you've gone through the different versions of Kubernetes, has been getting smaller and smaller and smaller. It's still, I think, a few thousand lines of code, but you can see how K3s and Kubernetes are converging with their ethos. So I think because K3s is able to be a lot more opinionated and just pull out this code today and leave it up to the user to decide, whereas upstream Kubernetes can't, it's got to support this legacy platform. I kind of see that convergence of the two code bases, but the provisioning side of K3s is something very unique to it, and I think something that will keep the project around even if the upstream kind of code base is very similar. Upstream K3s isn't trying to solve that provisioning problem and is leaving it to projects like K3s or KubeADM to solve that.
Yeah, absolutely. And that kind of goes back to what I was saying earlier. K3s does take a lot of the hard choices you have to make out of which distro do I use, because it does ship everything that you need to run Kubernetes.
There's actually a question in the Q&A kind of touching on this of what should one keep in mind while choosing K3s over K8s, and I guess like my thing would be twofold. One is your sort of resource constraints, I guess, in many ways, because K3s is still very lightweight compared to, as far as I understand, compared to full fat Kubernetes. But the other one is sort of how deep do you want to dive, right?
Yeah, absolutely. One of the main differences between K3s and a lot of the other traditional Kubernetes distributions, such as KubeADM, specifically KubeADM, you have your API server, scheduler, and a few other Kubernetes processes that are actually run as pods inside of the Kubernetes infrastructure itself. Whereas K3s, those have been moved into the binary of K3s. So your API server, the SQLite database or etcd database, the API endpoints, the scheduler, and a couple of other things that are in kubeadmin as pods are all in one binary running in the host namespace. So effectively, you're just moving things out of Kubernetes so that you can resource constrain them more by being able to share memory and things like that.
Quick question, actually, sort of on the differences, while I have David and Dinesh here, is high availability differences between upstream Kubernetes and K3s, because K3s by default ships with one control plane, right?
Yeah, so that's kind of on their decision to go with SQLite because it's a lot easier to manage. Sort of the problems around etcd is that it's quite easy quote unquote easy to get set up, but you quickly start running into issues about, how you back it up, how you keep it running, or how do you do a restoration, and what happens when the database grows. And keeping on top of that is actually it's a task in itself. Whereas SQLite, it's a lot easier and it's a lot simpler to understand. We've been running it for a lot longer. So keeping that up and running and backed up was very, very easy, which is a really good decision. However, you can only run that one copy. K3s have recently, I think in the last year, maybe year and a half, allowed you to run etcd as the backend, and you can do clustering. And K3s have done a lot of work to get that etcd clustering working, the backup, the restoration, all done for you. So that HA question has kind of gone away for K3s, if you obviously choose to use etcd as that control plane backend database.
I believe in addition to etcd, like you can use MySQL or Postgres or whatever if you need a bigger cluster, which I believe like upstream Kubernetes, it's only supporting etcd.
Yeah.
Okay. Cool.
Yeah, in the end,
like,
Kubernetes data is just JSON, so the database backing doesn't really make too much of a difference.
Yeah, I mean, there's an interesting deployment of K3s where you've got, if you've got an existing database cluster that you know and you trust and you manage, and you can create databases inside that you can almost palm off to another team. Like my DB team, just give me some database space, and then you can just start launching K3s clusters against it, and you know that your management database is all backed up by someone else, and you just give someone else the problem. It's an interesting way to look at how you do backups for control plane.
Thanks for the question, Kai, and thanks, Dinesh, for answering. While we have Dinesh and David over here, it's also to talk a little bit more about, from the company standpoint, how Civo uses K3s, and a little bit more about where we are headed.
Yeah, so I mean, kind of all of the topics that we've covered around why K3s is really good about that startup time and ease of configuration is why when we chose to build the managed Kubernetes service is we went down that K3s route, because a lot of those problems were solved by K3s, and all we need to do is do some initial configuration files, which are YAML files that we put in the root of the servers. And then they can kind of all boot up and join in to make a cluster together. And then K3s handles a lot of the runtime, kind of looking after and babysitting of a cluster for us, which is really, really good.
Thanks for sharing, Dinesh. David, do you have something to add onto that? Tech issues? Can't hear you.
I think we've lost David. Right. What I'll say to that is kind of in terms of like how does Civo use K3s is we use K3s in the sense that customers use it, right? As in, when you start a cluster, you start, but underneath what the sort of platform stuff, we've decided to go in a different direction.
Yeah, and I think that's more historical about where the projects were. I mean, when we started working on Civo as a platform, it was 3 years ago is when we started the technical journey. And K3s at the time didn't have etcd as an option for HA control plane. And when we're building our platform, is that was key. We couldn't launch on our hardware a Kubernetes cluster that didn't have HA for the control plane. It would be absolutely crazy. So we had to kind of go down the full fat K3s route. If we were building it from the ground up today, I think K3s would be a serious contender with the etcd option it now has. So
yeah,
I think just remembering. Okay.
No, I was just going to say we were in beta when Darren Shepherd from Rancher and of the sort of K3s team joined us, and he just sort of went, oh yeah, like we can do high availability control planes now, and you just sort of typed stuff into a terminal and out popped an etcd backed cluster, and we were just like, you're just pulling this stuff like magic.
Yeah, Darren is something special to have got K3s kind of on his own to where it is today, pretty much.
Yeah, I think it was mostly him and maybe two other people. And yeah, if you're watching this on playback, go back to the Civo YouTube channel and look up the Darren Shepherd K3s talk. It's about 2.5 hours, but it's so cool.
Mhm.
Speaking of architecture, actually, so I've just seen that Saurav has asked that
Yeah.
if my project is in K3s and what happens after some time, you need some features of upstream Kubernetes. Well, depends on what the project is, right? Is if it's an app, deploy it build up a new cluster and deploy it there. That's the beauty of containerized applications. The architecture's decisions should be and are separate from your application decisions.
And K3s has got upgrades built in as well, so you can kind of go. I'd always suggest go version by version. Don't do a big jump from skip over major versions, but you can do that. I think you've always got to be careful when you do that. Read the release notes for Kubernetes and make sure that you're not using any either depreciated APIs or anything like that. So yeah, you can just upgrade in place. But I think the beauty of K3s is if you've got the resources, you can spin it up and migrate your application, and you kind of always know you've got a clean state to work with.
I believe that answers the question, and it's the whole beauty of containerization. But wrapping up with obviously questions we've already gotten, but just as a closing remark, what should one choose?
If I were doing it for any project today, I think my first choice would be K3s to deploy on, rather than like a full fat upstream K3s with having to manage a kubeadm install and get all of the HA set up. I think for most projects that will be sufficient.
Yeah, absolutely. It's one of those cases of not knowing where your complexity is going to end. When you start off, nobody is really going to be starting their Kubernetes deployment at the point where K3s is going to have its limits exceeded. It's going to take a while for them to push that envelope outwards to really get to the fringes of where Kubernetes and K3s differentiate. And when they do, K3s doesn't really have anything that binds you to K3s. There isn't any new K3s methodology to using Kubernetes. You should be able to simply transplant that to a more complex Kubernetes distribution if you need that. So yeah, it's, of course, using the Civo platform, I use K3s all day long, and I have not really run into any limits myself, even pushing at the envelope purposely.
I think also K3s is solves a lot of the problems you don't know you will have. Take, for example, DNS of there is a requirement in Kubernetes, all Kubernetes distributions, that all node names must be resolvable by DNS, which usually means either putting these in an upstream DNS server so they can all be resolved, or putting etc host entry into every node in the cluster for every other node. And if a host name ever changes or an IP address ever changes, you need to orchestrate across that, all nodes in your cluster. K3s does that for you, and it does that with the agent binary that it has on all of the servers. So, it's a problem that you'll never have if you run K3s, and you'll never need to think about. But if you're running upstream Kubernetes and you suddenly realize, hang on, this one node I can no longer do kubectl get logs from. Why is that? Everything else seems to work, but I can't do that. You then start going into this rabbit hole of trying to work out what the problem is. And that, at the end of the day, isn't delivering you business value. Business value isn't working out why DNS isn't working on this one part. Business value is deploying and running your application. And K3s gets you a lot of that for free.
Thanks for sharing, everyone. I believe you answered all the questions as well. Cool. Amazing. Thanks a lot for joining, everyone. I believe those are all the questions we had. And if you want to learn more about what we do, you can check out civo.com. To sign up, you'll get $250 worth of free credit. that you can try out. You can check out our initiatives. You can check out the Civo Academy. Want to learn more about Kubernetes? Search, and we do regular meetups. So keep an eye out on our webinars page on civo.com. Everything you can find over here. And yeah, we just crossed 10,000 on Twitter. So we'll be doing a Twitter space as well very soon on, so we have a 4-day week culture, 4-day work week. We're going to do a space on that soon. So you all can join that. We'll announce it soon. And yeah, thanks for joining everyone. See you in the next one. Great day. Bye.